In a previous lesson, we talked about solving equations and solving equations in order to use substitution. And in order to do that, we need a single letter on one side of the equation so that we have an equivalent expression that we can substitute into other equations. Now, in those examples that we did, we always had a letter y or x that was already by itself. But in many systems, that's not going to be the case, and so we're going to have to do that for ourselves. So I wanted to talk real quickly about a couple of things in solving equations so that we can make a good choice when it comes to solving an equation for a variable. And the first thing I want us to think about is when it comes to solving an equation, we always get it down to a place where we have the letter that we're solving for and with this number in front, if there is one, on one side, so that our last and final step will always be to divide by that number, because that's going to give us 1x, or the number x, or the letter x, excuse me. And then we divide the other side by the same thing. Now, it's nice when this number over here is evenly divisible by this number over here, because it gives us a nice whole number or an integer. What becomes challenging, if it's going to be challenging at all, is if we get this letter by itself and we have a number over here that's not divisible evenly. We still divide by that coefficient as our last step. This side divides evenly because we're dividing by that coefficient, and this side doesn't, and so we end up with this fraction. Okay? Now, there's nothing wrong with a fractional answer, except that if we're going to now substitute this into another expression, because the equal sign tells me that the letter x and the number 7/4 are interchangeable, if I have to substitute in the 7/4, then I have to work with fractions, which can be a little bit difficult. So if we could avoid this scenario where we ended up dividing by a number where this was not divisible by that, then we would not have to run into fractions. So when we're looking at systems and we're looking at what letter to solve for, we want to look for a couple of things. The first thing we want to look for is any letter that has a coefficient of 1, meaning there's no number in front of the variable that's written. Because if I have a coefficient of 1, then once that letter is by itself, it's going to be solved for. There isn't going to be a need for dividing. So if we look at equation number 1 here, I can solve for x or for y. I notice that the y has a coefficient of 1, meaning there's a 1 there even though we don't write it. There's a coefficient of 1 that's written there. So it would be best if I went ahead and solved this equation for the letter y, because in doing so I'm simply going to have to subtract 3x from both sides, and so that's going to give me y equals 12 and then minus the 3x. So now I have the scenario that I want, where the letter y is by itself on one side of the equal sign, and then I have an equivalent expression that can be substituted into the other equations. So if I can, I want to look for a coefficient of 1. So if we're looking at equation number 2 here, I notice that the x has a coefficient of 1. So in this case, I'm going to solve for x. And again, by adding the opposite of this 5y here to both sides, I'm going to get x equal to that 17 minus 5y. And again, I have what I need. I have the letter isolated on one side with an equal sign, so I have an equivalent expression that can be substituted into the other equations for the letter y. So if we look at question or equation 3 here, again I have x, but notice that it's negative x. And I do then need that x to be positive, so what I'm going to do is I'm going to switch things up here and add x to both sides. Okay, now that's going to give me 2y is equal to 11 plus x. X is not by itself, but now I can move this 11 to the other side by subtracting that, and so that's going to leave me 2y minus 11 is equal to x. So now I have the x by itself and it's positive, and again I have an equivalent expression that can be substituted into the other expressions. Now, what happens if we don't have a coefficient of 1? Okay, as in we look at number 4 here, x has a coefficient of 4, y has a coefficient of -8. What I want to do in that case then is my second best option is to solve for the coefficient, or solve for the letter that has a coefficient that will evenly divide into all other terms. So evenly divides into all other terms. And the reason I want to do that is because, again, if we think about solving an equation, the last thing I'm going to have to do is to divide by this number. So if this number evenly divides into 12 and everything else that's over here, I'm not going to end up with this fraction nonsense, or not nonsense, but this fraction thing that I would if it's not divisible into all of the other terms. So if I take a look at number 4 here, this 4, if I choose to solve for x, 4 goes into this 8, so that's going to be a non-fraction, and this 4 divides evenly into 12, so because that 4 divides evenly into those other two terms, then I will have a variable solved for where I won't have any fractions involved. So the first thing I would do would be to add the 8y to both sides. So that would give me this 4x is equal to this 12 and then plus 8y. And then the last step to solving an equation is to divide by that coefficient here. So I would divide by 4. The 4 reduces, leaving me x. The 12 divided by 4 is a 3, and the 8 divided by 4 is a 2. So because I chose to solve for the x where that coefficient divided evenly into all the other terms, when I get finished and I have x by itself, I have an expression over here that does not contain any fraction. If I looked at number 5 here, 9 does not go into 3. Or 12, so I don't want to solve for x. The -3y, however, 3 does go into 9, and 3 also goes into 12, so I'm going to choose to solve for the 3, or for the letter y here. I need to make myself a little bit more room, so let me do this. Okay, so I'm going to solve for this 3y. Now again, it's negative, so I'm going to start off by making that positive by moving that to the other side, by adding its opposite. So that's going to give me 9x is equal to 12 plus 3y. I'm then going to move the 12 by adding its opposite to both sides. So when I do that, I've got -12, a positive 9x is equal to 3y. I now am going to divide by this 3, and because I've chosen to divide by a number that goes evenly into everything else, I'm going to end up with no fractions. So this is going to be -4. This is going to be 3x. And then this is going to be y. So again, I have a letter where it's by itself, and I know because it's an equal sign that it's of equal value with this expression, so I can substitute something into another equation that doesn't have any fractions. Now, that's nice if we have a variable that has a coefficient of 1, or we have a variable that divides, that has a coefficient that divides evenly into everything else. But sometimes, as we have in this last expression, we don't have any of those options. 4 does not go evenly into 5 or 11. 5 does not go evenly into 4 or 11. So there's no choice here. I'm going to have to work with fractions. So in that case, I simply choose to solve for 4x, or I choose to solve for 5y. It doesn't matter. You get the letter by itself. You have some fractions you got to deal with, but we can deal with those after substituting in, and we'll do some examples when we are actually doing the worksheet. So in this case, let's say I chose to solve for this, so I'm going to subtract the 5y from both sides. So that's going to give me 4x is equal to 11 minus 5y. I then am going to divide by 4, and again I have to do that to every term. Pen's not working very well there. So that reduces, leaving me the x by itself. 11 over 4 doesn't divide evenly and doesn't reduce, so I'm stuck with that fraction. And then 5 over 4 does not reduce and does not divide evenly, so I'm stuck with that fraction. So I do have an equal sign. I do know that x and this expression over here are of equal value and are therefore interchangeable. I can go ahead and solve my system by substitution. I'm just going to have to deal with those fractions. So try to make a good choice if you can. Look for a coefficient of 1 first, solve for that letter. If that's not available, try a coefficient that would divide evenly into every other term. If that doesn't work, then just pick a variable, solve for it, and you'll have to substitute using fractions.